Hello, this is Ms. DB. In this video, we are going to look at graphing rational functions. So on your worksheet, the first thing you learn about is some vocabulary about what a discontinuous function is. So discontinuous. It's a function whose graph has one or more gaps or breaks. And a continuous function is a graph that has no gaps or breaks. So far, all of the functions that we've looked at, linear, quadratic, polynomial, exponential, log, they're all considered to be continuous functions, but now we're going to look at discontinuous functions. If you look at this example of a rational function, you will see that there is a gap in between the two parts. The blue curves, those are the graph of this rational function, f of x equals 1 over x. And the gaps mean that it's a discontinuous function. The gaps also are going to indicate where our asymptotes are. There is both a horizontal, the red asymptote, and a green vertical asymptote in this problem, in the graph of f of x equals 1 over x. An asymptote is a line that the graph gets closer and closer to but doesn't touch. So you will see here that both of these asymptotes, the vertical will always be x equals that number because it's going through the x-axis at a certain number. So it'll always be x equals whatever that number is, and the horizontal asymptote will always be y equals that number. So it's wrong if you just put a number. If you just wrote the asymptote as 0 and 0, that would be wrong because asymptotes are lines, they're equations, so they need either an x equals or a y equals in front of them. Next thing we're going to look at is the transformations of rational functions. So this graph up here is the parent rational function. It's the simplest rational function you can get, f of x equals 1 over x. But we can change that function and we can change the equation, and when we change the equation, it will transform it so it looks different. So if there's a number besides 1 up here, then that's changing a. And if it is less than 0, then if it's a negative number, then it's also reflected across the x-axis. But the value of a tells you if there's a vertical stretch or compression. So if you have a number besides 1 here, there's a vertical stretch or compression. If you add a number after the fraction part, then that's a vertical translation up or down. So if you add a positive, then it's moving it up. If you subtract a number, that's moving it down. And then in the denominator, that's where we find if it's moved left or right. If it's x minus a number, it moved to the right. If it's x plus a number, it moved to the left. So let's look at an example problem. And we're going to look at g of x equals 1 over x minus 2 minus 3. So let's look at some different things. First of all, you can use technology to make a graph. Here's a graph of this problem here. Go over just a little bit. You can see that it's discontinuous. There's two separate branches of it. There's two parts. And it will have a vertical asymptote and it'll have a horizontal asymptote. So you can tell from the graph or from the equation that the vertical asymptote is at x equals 2. We can tell that from the equation right here, because if we set x minus 2, the denominator, equal to 0, we would get x equals 2. That's the vertical asymptote. That would be the line. I'm going to draw a line here, right there. Let me try to get that in there. I'm using just a pencil tool, so it'll be a little bit. Let me see what colors should we use. For vertical asymptote, we'll use green. So let's see how straight of a line I can get here. It's going to go through right at 2. I'm trying to make it a dashed line because it's going to get closer and closer to that line, but it'll never touch it. So that is the asymptote x equals 2. And then the horizontal asymptote, I'll do that one red, and we can tell the horizontal asymptote is going to be right at y equals negative 3. So here's y equals negative 3. right along here. And from the equation, we can find the asymptote from the translation that's up or down. And in this case, it was going down. So we know the translation, or the horizontal asymptote would be y equals -3. It matches this. But you have to put in a variable in front of it, the y equals in front of it. We can also tell that this has been moved. It's not in the same spot as our parent function, and it has, we already talked about, it's moved down 3, so it's a translation 3 units down, and it's also been translated 2 units right. And we can tell that from this, of course, is the translation down 3 matches this part, and the translation left or right is this. This tells us that it's moved 2 units right, which also helps us find the vertical asymptote. So both the equation and the graph can help us answer these questions. So on these problems that you're going to do, 1, 2, and so on, you're going to answer questions similar to that. You're going to find the values of A, H, and K, and then you're going to find the asymptotes and talk about the transformation. So there's 2 of them. Let's look at number 2. So on number 2, it says g of x equals 1 over x minus 1 plus 3. A is the number that is right here. That's A. And our A is just 1. Our H tells us how far left or right it goes, and that is the number that's added or subtracted from x. The default is x minus a number, so our H is just 1. And our K is the number that's added or subtracted from the end, if there is any. So our vertical asymptote we're going to find from the this part here, and our horizontal asymptote will be the up or down part at the end, and the transformation can be found from those as well. Before I write these out, let's graph this. So in Desmos, I'm going to open up Desmos, and I'm going to put in the g of x is equal to 1 divided by x minus 1 plus 3. All right, let me show you that graph. So here is the graph. Here's the function. When you type it into Desmos, you have to make sure to put parentheses around the denominator and then close that out. So if you were just typing 1 over x minus 1 plus 3, look at that's a totally different problem than what I wanted. So you need to get out of the denominator, either by moving the arrow over or by clicking over and then putting the plus 3. And this one worked without putting parentheses around the denominator, so you might be able to get away with that. But make sure when you're done that it looks exactly like it's supposed to look. So here's my function. I can see several things have changed from the parent function. The parent function is g of x equals 1 over x. That's the green. So I can see that the red, mine, has moved up, and in fact it's moved up 3. I can tell that from this. So the translation will be up 3, and I can also tell that the horizontal asymptote will be y equals 3. That line y equals 3 is the horizontal asymptote. It will never touch those red lines. And I can also tell from the equation what the vertical asymptote is going to be. I can tell that the vertical, and I can tell it from the graph too. It looks like it's at x equals 1. If you took the denominator of x minus 1, set it equal to 0, and added 1 to both sides, you would get x equals 1. That is the vertical asymptote. So we've got lots of information just from this. To share your graph with me, you can either take a screenshot of it, or you can get a link from the Share Graph button. So you need to attach these to your worksheet when it asks you for the graph. And you can either do the link, click it once, or you can do a screenshot, or both if you want. And I'll just take a screenshot so I can see it at the same time. And needs to include both branches of the graph. If your graph is so zoomed out that it looks like it's just on the X or Y axis, or if it's so zoomed in that you can only see part of the graph, then that would not be correct. So let me show you what that would look like. If you were graphing this and you were so zoomed in that I only saw like a piece of it, that's not correct. That does not show the whole graph. Or if you were so zoomed out that you can't tell what's happening, something like this, that's also not a good graph. So make sure that we can see both branches of your graph when you attach your graph, and you can tell what's happening. It's close so that you can see like where the asymptotes are. Things like, is there any y-intercepts? Things like that you should be able to tell from the graph that you attach, or the link that you attach should be set up correctly. So on the worksheet, I'm going to type in those questions that we had answered. We said that the vertical asymptote would be at x equals 1. And we said that the horizontal asymptote would be at y equals 3. And the transformation is it went to the right 1 unit. It's a translation. And up 3 units. So that can be told from the asymptotes, it can be told from the graph, it can be told from the equation. So all parts have now been completed for that one. There's some other things to talk about, like domain and range. The domain will have something that you cannot let it be equal to. The vertical asymptote is what the domain cannot be equal to. And the horizontal asymptote will tell you what the range cannot be equal to. So the vertical asymptote of this example is x equals -2, because that's what we have in the denominator. So the domain would be all values of x, except x cannot be -2. And the range, the horizontal asymptote is y equals 4, because it moved up 4. And that means that the range would be all values of y, except y cannot be equal to 4. So if you're asked to give the domain and range, make sure to look at the graph and or the equation and the asymptotes in order to answer those questions about domain and range. So for 3, 4, and 5, you're going to do the same thing as before, which is make a graph, describe the transformation, find the vertical and horizontal asymptotes, and also give the domain and range. And the same thing for number 4 and 5. Let's do one more problem. Let's do number 5. So we're going to first graph it. So in Desmos, we will graph x plus 8. So you might think that it's going to move to the right 8, but this one's actually going to move to the left 8. It's kind of the opposite of what you think. Move the graph over so that you can see what it looks like when I graph that. But you'll notice that I don't even see it. It moved so far over to the left that now I can't see it. So I'm going to zoom out a little bit until I can start to see it. Well, I can see a piece of it there, but that's not enough. Oh, look, it's down here. So I'm going to zoom out a little bit more, and most of the action in this graph is taking place in the third quadrant down here, so that's the part that I really need to look at. And I could also change the scale of just the x or y axis to get a better view if I need to. In this one, it was okay to just zoom out to find what I needed. So let's see what's going on here. I've got the parent function, if I show that again, is up here. So it's definitely moved over to the left and down. And the equation will help you see how far left and down it has gone. Did I type in the wrong one? Oh, I was supposed to go -1. I was supposed to go down 1, not down 8. So I'm going to fix that. That's easy to fix because all you have to do is change the technology. So now we see it only moved over, or only moved down 1 unit, not down 8 units. I'm going to adjust my view here, hide the parent function so I can see better what's going on. Now I see it's taking place more in the quadrants 2 and 3. So my vertical asymptote, that's this one here, would be at x equals, well, I can't quite tell what it is, but I can tell from this that it is x equals -8. Going to submit this, and then the vertical or the horizontal asymptote is right here, and if you can't quite tell, it will be equal to how far down you went. So y equals -1. So those are the asymptotes. Let me get a link to this graph to share and put it on the worksheet. So you don't have to have a screenshot, you can just have the link. I can click on the links as long as you put a space after it. The vertical asymptote we talked about, that was at x equals -8. We found that. And we found the horizontal asymptote was y equals -1 because it moved down 1. Now what about the domain and range? Let's look at the graph again. The domain is all the x values here, all the x values here. In fact, it's everything except for the vertical asymptote. It's everything except -8. So you can write all real numbers except -8. And for the range, it's going to be all real numbers except -1. And that's all you have to do. Let me know if you have any questions. Thank you very much.